I've met definitely most of you. My name is Austin. Today we are going to be talking about CSS. So I know CSS is probably not the favorite topic of every engineer, but I think there's some important things to know about it that'll help you solve any styling problems and just write better, cleaner CSS in general. I also think CSS can be incredibly cool and fun to work with. I'll give you an example of that here shortly. So today's schedule, so first we'll start with some simple CSS foundational tips, just on like how styles are applied. Next, we'll get into some responsive and static web design, focusing mostly on responsive design. And then we'll start to get into some good CSS tools and wrap it up with some React specifics. So real quick, there's a lot to go through here, and there will be a lot happening here. I have slides, I have live code demos, I have browser demos, so please just bear with me as we jump around. And as always, feel free to stop me, ask questions if you feel like I'm going too fast. Yeah, please pipe in whenever you need to. So let's go ahead and get started in Mentimeter. Where's my Menti? How's your CSS? Are you guys all able to get into this okay? Cool. I think this is kind of the general consensus where most software engineers kind of fall into this basket of like, I'm okay at it. We will get into some cool tools down the road that help us sort of like write less CSS. Next question, just a fun one. Anybody tell me, what does CSS stand for? All right, you guys got this one pretty quickly. So cascading style sheet. We will get into the cascade portion here shortly. Okay, so we're going to step into some of the foundations of CSS, but first I want to show you this site. It's just an example of some really cool CSS. My brother showed me this site about 6 or 7 years ago, and I just keep it in my back pocket of just an example of what you can really do with CSS. So let me go ahead and pull this up just to get everybody excited about learning some CSS. Okay, let's just go back to their homepage. So keep in mind that this is all largely CSS. So as you see these kinds of things, like this is all like images of half the letters they've created. This is all just CSS animation. They've added some really nice touches. So as you start to scroll, things come onto the screen really nicely. You've got these nice airplane animations that follow you down the page. If anybody else sees anything cool as we kind of look through this, you want to point out, feel free to unmute and let us know. So you continue to scroll. Give this a second. The airplane continues to follow you down. So we won't go through all of their pages, but we'll go through a few. This is one of my favorites. I think this is so cool. Keep in mind, again, this is all just built in CSS. And so they've built for their work like an old school cigarette machine. So as I click this, pay attention to both the pull tab and the fake cigarette box up here. But this is all animated before you go to the next page. They have all kinds of, again, this is all just built in CSS. Not a lot of programming here. And their contact page is really cool as well. I think these buttons are actually photos. But yeah, so CSS can be a ton of fun to work with. I mean, this is the kind of stuff that, like, if you asked me to write CSS all day, I'd probably say no. If you asked me to write CSS all day to develop stuff like this, I'd probably say, heck yeah, I think this it becomes a lot of fun, and you can make some really beautiful components and websites with just purely CSS. There's a deep rabbit hole to go down if you'd like to go down that some other day. Okay, so let's go back to the learning portion of our program. Here we are. So some of this may be a bit of a review, but I think it's important to keep these things refreshed and at the front of your mind when you're styling. So the first thing is the box model. So I'm sure we've all seen this box before, but I think it's an important recap and a point to make that everything in your page is contained in a box, whether that be images, text, shapes. Everything goes in a rectangular box, and every box has its own dimensions that can be assigned, or every part of that box has its own dimensions that can be assigned. So first we have the content, which is, kind of the most obvious thing. It's the thing that we're putting on the page. Around that, we have a padding and a margin. Can anybody tell me the difference between padding and margin real quick? Let's see, who am I going to pick on?
Padding is inside the box and margin is distance between boxes or outside the box.
That's a great way to look at it. I like that explanation of the distance between boxes for the margin. So yeah, so padding is inside your border and your margin is outside your border, or as Jonas put it, the distance or the width between your boxes. And then we have the border in the middle. The border is kind of the most important piece because this is really like what sets the dimensions of our box, but we don't do a lot of styling with the border itself. Every now and then we'll add a border radius or give it a quick weight. So let's go ahead and take a look at that in some code and in the browser. So as you can see, everything's just a box. And the real point to make here is so you can see, actually real quick, let's go through this component because this component will come up in a lot of my code demos. It's a pretty simple component. There's one container div. Inside that, there's another container that's a header that's sort of acting as a body here. And then there's two divs. One of them has an H1 and H3, two headers, and one of them has two paragraph text. So or two hunks of paragraph text. So we'll be working with this component throughout the day. Let me know if you guys need to stop and like read any of this to understand it. But the important thing to notice here in the box model is just that we have this div that is the box model title container. And so we've given this some pretty hard dimensions. We also have this H1 in the middle. And so this H1 doesn't have any hard dimensions given to it. But if we go ahead and we look at our browser, we can see that the H1 has a box around it as well. So fairly obvious, but again, just remember that like hammered in your heads that everything works inside of a box. All right. Back to our slides. Okay, so there are two ways to style and size our boxes or elements, and that is extrinsically and intrinsically. So extrinsically styled elements have hard dimensions. Intrinsically styled elements are sized in relation to the content inside or around them. So we'll mostly be styling things intrinsically. And in order to accomplish this, we'll use properties like view widths, view heights, percentages, or other CSS rules and identifiers that relate to content, such as min content or max content, as opposed to giving things like hard pixel widths. And so this allows our boxes to change size with our content, so we don't have content flowing out of one box and into another. And so we can go ahead and take a look at this in some code as well, and bear with me as I hop through all of my files here. Let's go ahead and split this out. Can everybody see this okay? Okay, cool. So you can see down here, I have an extrinsic container and an intrinsic container. Over here, this looks like, where's my beautiful nav bar up here? Here we go. So we have two boxes. And so you can see if we start to add a bunch of text here, just get rid of this real quick and we'll watch it live in action. So you can see we have two boxes. This one's been given some very rigid dimensions. This one has been styled to the minimum content. Where is my, here we go, extrinsic container. So we have hard pixel widths, and our intrinsic container, we've set our height to min content. So if we just start adding a bunch more text to these things, we can see that the box over here expands. This one does not. So just important thing to remember that when you're using hard pixel widths, that you may run the risk of having things run outside of your container. And so really, as far as the pros and cons, it's a trade-off between flexibility and how much the browser does for you. So an extrinsically styled component gives you absolute control over your styling and layout, but it's not really flexible. And so an intrinsically styled component is flexible and it'll fit the box around whatever we're trying to put on the page, but we are handing some of the control over to the browser. Sometimes that's a good thing. We want to lean on things that will do things more for us, but we are handing over that control. So just something to make sure we remember is that we do lose some control as we start to style things intrinsically. Any questions so far? Cool. Okay, so we're going to get into inheritance and specificity here. So these are two parts of the cascade and cascading style sheet. You can go pretty deep into a rabbit hole of what all the cascade is, but really the thing to remember here is the cascade is just an algorithm that the browser uses to decide which styles get applied to which elements. So inheritance and specificity are important to understand because it'll not only help you understand how your styles are applied, but it'll help you troubleshoot and make your styles more maintainable. So we'll start with specificity. Specificity is the means by which the browser uses to decide which style to apply to an element when multiple styles have been defined for said element. So if we look over here, we have a button and it also has a class myButton, and both of these things have been styled. So specificity is going to run through an algorithm, which we'll get into here in a minute, and figure out which of those styles to apply. And inheritance is how the browser decides to style child elements when we don't give it a specific CSS rule for that element. Okay, so hopping into some more specificity. So there is a method to the madness of how browsers handle conflicting styles, and it's done by a point system. Has anybody seen this point system table before? Just raise your hands. Okay, so we'll run through this real quick, but basically the idea is different CSS selectors are worth different amount of points, and the CSS rule with the most points wins out and is the one that gets applied. So the universal or this asterisk, we don't use this very much. It's worth 0 points. And we have things like elements and pseudo elements. So if you're targeting something like a div or your paragraphs, it gets 1 point. Classes and pseudo class attributes, classes, pseudo classes and attributes get 10 points. An ID gets 100 points. So it's really important. I think this one's very common is knowing that like an ID over a class, an ID is going to have more specificity points. Inline styles are at 1,000 points, so they're really important. And then there's always the important tag, which is the exclamation point important. It's worth 10,000 points, which is the maximum amount of points that you can have. So what does this look like? Well, the more selectors, especially like high point selectors that we add to our rule, the higher the specificity score is. So keep in mind, the specificity is altered in the CSS rule, not by adding a bunch of things to our elements. So we don't want to go and just like, oh, I need some specificity here and add a bunch of like ambiguous classes if we can avoid it to our elements, but rather we want to add the existing classes, IDs, attributes that exist on the element to our CSS rules. So the goal is also to have just enough specificity to ensure our style is applied without going so high that it's hard to change the style. So if we have something and it's got like 9,000 specificity points, it's going to be really hard to maintain if we ever want to change or rewrite that style. So have enough specificity to make sure that those styles are applied and solid, but don't go too high. And so let's go back to a quick coding demo over here. Let's pull up specificity. Okay, so we're working with the same component. Here's our CSS. Real quick, let's just go take a look at the browser. Well, this text is already blue. Should be red at this point. Oh, because I've already targeted it with this ID. So you're that. Okay, so it's red. So let's go through and figure out how through specificity we can go ahead and make that text blue. You already saw one way that I gave away. We can go ahead and target its ID. We know that the ID has more specificity points than either of this specificity paragraph text or this blue text. So at this point, we have 100 points up here, and we are at 20 points on both the blue text and the specificity paragraph text. If we just remove this from the equation, we can see that the specificity paragraph text is going to be the one that gets applied because CSS applies the lower the rules lower on the page first. But without just outright changing this class, say we want to keep specificity paragraph text on this element, we also have it elsewhere. We don't want to change it. We can go ahead and target that by here. We'll even put it above. Let's just add to this one. We add both. Oh my goodness. Paragraph text. So now we've had both of these classes applied to our CSS rule. And so instead of having 10 specificity points, we are at 20 specificity points. And if we go over and look, hey, our text is now blue. So this 20 specificity points beats out the 10, even though that this one's lower in the page. Any questions about specificity before we move on? Cool. Okay, so next is inheritance. I think we've all seen inheritance in action. There's a few caveats and details I want to talk about real quick. One, only certain CSS properties can be inherited. If you're wondering why certain styles in a parent element aren't being applied to a child element, just check to make sure that that style rule is one that can be inherited. There's a long list of styles that can or can't be inherited. I don't expect you to remember them. I don't remember them, but just be aware that not all styles inherit, and it may be a lookup you have to do if you're struggling there. Two, inheritance only cascades downwards. This may be fairly obvious, but a parent or sibling component will not inherit styles applied from the related child or sibling. So I'll show this in code in a minute. And three, if we want more control over an inheritance, there is an inherit keyword. So let's take a look at some inheritance in code. Inheritance. Okay, so again, excuse me, I have hiccups. Same component, but you can see we have this inheritance container. Oops. Inheritance content container here, which surrounds our two paragraph tags. And then we have inheritance paragraph text, so we can style these things directly. So if we come over here and look at what this looks like in the browser. So we want to make all of this text blue with a size 24 font. So instead of targeting individual paragraph elements, we can go ahead and add these things to the container. Let's make it blue. Let's give them a font size 24 pixels. And so even though we didn't directly style these things, these paragraph elements, they were inherited from the parent container around it. So another important thing to note is that this goes vice versa. So if you don't want to style the whole thing and you want to style these things individually, we can style them individually as well. So just a thing to keep in mind, maybe you're running into conflicting styles. Maybe something's inheriting that shouldn't be. Also, just to make the quick point that applying thing to one paragraph tag inside a container does not apply the style to every paragraph in Z container, unless we go ahead and apply the style to the parent container. Any questions on inheritance? No? Cool. I think this is probably a review for most of you guys, but again, I think these are the kinds of things that whenever I run into trouble with CSS that like I keep at the front of my mind that really help me sort of like get to the root of how my styling works. Okay, so let's move into some responsive web design. So responsive web design allows our elements to change sizes or reorganize on the page based on the size of our browser window. whether that be resizing the browser window on your desktop or using a different device like a tablet or a phone. Static web design keeps everything the same no matter what. And this is the way things used to be. I don't know if any of you guys are old enough to have experienced the internet in the old Netscape style up here. But if you're on a smaller screen or something like your phone, you have to do a lot of both vertical and horizontal scrolling. Oops, excuse me. To see everything on the page. And so for that reason, static web design has mostly gone out the window in exchange for responsive web design. And you can sort of decide how responsive your app will be. For example, if you know your app is only going to be used on a desktop, you probably don't need to handle responsiveness all the way down to a mobile phone size and vice versa. If you know your product is going to be a phone app, you probably don't need to make it entirely responsive all the way out to like super large screen sizes. So let's take a look at an example of static web design over in code. Static. So you can see all of our styles here. Everything has everything is extrinsically styled. Everything has a hard pixel width or hard pixel value. So we're giving this a hard height of 1,000 pixels, a hard width of 1,000 pixels, and our font size is a hard 18 pixels. And so if we go look at this in the web browser, this is what it looks like, and this is what we get. But as you can see, as we start to move our page around, nothing moves, nothing resizes. So if we're down on like a mobile screen or a very small window, we have to start scrolling around the page to find everything within the window. So that is the main reason everybody has gone to responsive web design. So how do we do this? So first and simplest is to use responsive sizing rules. So this alone isn't going to make your site entirely responsive, but it's a huge help and a huge part to making things responsive. So using values like percentages or minimum or maximum widths, heights, view widths, etc., as opposed to giving things hard pixel values. So with these, we're basically just defining what percentage of the screen we want the element to take up, as opposed to how many pixels we want that element to take up. Oh, I'll show you the slide real quick that I forgot to go back to. But we're going to go right back to code. So as opposed to the static version, if we come over to our responsive version. Again, same old component. You can see now we have heights and widths that are set to view heights and view widths. So I don't know if you guys have seen this element before, but basically what this is saying is take up 100% of the current view's height or 100% of the current view's width. And then we've done a nice little calculation on our font size down here. And so by getting away from pixel values, we can get pretty far in the responsive scale here. So you can see this scales really nicely as we come down to a smaller screen size. And that's all done by just avoiding things like hard pixel widths and using certain CSS rules that go off of a ratio or a percentage. Any questions about responsive sizing rules?
You do have a question in the chat, Austin, but it was.
Oh, sorry.
Ours.
Where's my chat? Oh, here it is. It's over here. Is there a good rule of thumb for when you'd want to use extrinsic sizing? A good rule of thumb is hard to come up with. Let me think of like some good examples. So things like logos or images that you don't want to resize, say they're small enough and you always want your logo in the top left at a certain size, all the way down to you know, whatever screen size you're on. That could be a good example of when you might size something extrinsically, but it's when we want absolute control over where something goes on a page. We don't want it to move. A background is another great example. So say we have a background image and we don't really care that the you know, say it's like a big pattern. We don't really care that we see only a hunk of that pattern and it repeats later on, but we want that thing to be like a solid, hey, like we need this thing to be this wide all the time. I hope that helps. A lot of CSS, I think, is kind of intuitive. It just comes with practice is when you'll decide to use certain things. But yeah, extrinsic styling is good for things that you want to be on the page in the same size, in the same place all the time. So the next one is media queries. Who's worked with or seen media queries before? Tommy, Zach, Dale. Okay, so media queries are kind of the next piece. And before a lot of grid systems and Flexbox, this was the preferred way of making things responsive. Some people still may prefer it. I think that would be a little crazy to prefer this over the modern tools, but we still use these things today. And so media queries are mostly used to sort of clean up breakpoints, and we'll get into breakpoints here in a second, where whatever grid system or library we're using may not give us the exact result we had in mind. So a breakpoint, pretty simply, is the pixel width of our media where we want our styles to change. I think that's the easiest way to look at it. So as you can see in this example here, we are going to have a breakpoint at 480 pixels. Then we're going to have one that breaks between 900 and 901 pixels. So we can say that that's at 900 pixels. And then another one that will break at 1200 pixels. And so how this reads is we are reading media, and the media we want to read is screen. And so between our minimum width of 480 pixels and our maximum width of 900 pixels, we want, say, a button to be 200 pixels wide. And so as that screen gets bigger and we hit our 900 pixel breakpoint, we want to go ahead and widen that button out to take up a little bit more room on our page. And so we can bump that up to 400 pixels. So let's go ahead and take a look at that in code. We'll go ahead and pull this up first. Okay. Media queries. Okay. So first thing to notice here is that we have this MQ header class. And within our media queries, we are just changing out certain values within our MQ header class. So it's the same class we're targeting. And so all of the other things that we don't target here are going to stay the same across our media queries. So as you can see here, we have a breakpoint at 400 pixels. We're not handling anything below 400 pixels. So below 400 pixels, our plain MQ header style should be applied. And then at around 564 pixels, we want to go ahead and we want to make this thing a little bit smaller. We want to bump this down from 1000 to 500 by 500, and we want to reduce the font size a little bit. And then if we go up to like a medium-sized screen between 565 and 872, this is probably actually considered a small screen. We want to be somewhere in between that. We want to make it a little bit bigger. So we've covered ground between 400 pixels and 872 pixels, kind of jumping up from 500 to 750 to 1000. And this is pretty ugly on purpose, just so you can sort of see the jumps here. But as we get down, and usually a good way to do this is if like you're working with a grid system, you're like, hey, like this starts to overlap my text here. I need to go ahead and add a media query there, and it's going to jump. So now we're down to our 750 by 750. It's going to jump again. And then if we go too small, we haven't covered that. It's going to hop back up to the default. I believe that was called MQ header. MQ header. That's what I called that class. And then again, as we get, I don't know if my laptop screen gets big enough to handle anything bigger than that. Oh no, here we go. That's our default. So it's important to know that there's also other media that we can read. It's not just the screen. The print one is really nice. I've used this one a couple of times. If you need to print something, or really cheap hack for exporting a PDF is if you have the print window and just have the user do the export to PDF thing. Again, pretty hacky thing to do, but you can do it. And so you can like restyle your entire page based on the print window as opposed to just your screen sizes. So print is another good one to use, but just know that there are other media tags out there where you can affect the styles per media per size. Any questions on media queries before we move on to the next? Cool. Okay, so Flexbox. I think you guys have all used a little bit of Flexbox. It's short for flexible box. It's simply a more efficient way to lay out and align spacing between your elements. It gives our CSS boxes the ability to best fill the available space with its content. That's sort of the idea behind how Flexbox sizes things. It's also direction agnostic, meaning we can arrange our elements both horizontally and vertically. Let's go see some Flexbox in action. And I will have some fun Flexbox exercise for you guys after this little presentation. Flexbox. Okay, so this component's a little bit different. Let's just walk through it real quick. First, we have an outer container that's main container. Then we have a flex container inside that. It's just a container, given a class name of flex container. And then inside that, I've just got 4 boxes. And so you can see inside our flex container, we've given it a display of flex. And we've also given it a flex direction of row, justify content, space evenly. Let's go ahead and start center on this one. And then flex wrap, we've given it a wrap as well. So if we go and take a look at this, Flexbox has gone ahead and laid this out quite nicely for us. It's centered everything. Everything butts up butts up to each other. But so far this is a pretty nice layout. There are some other neat tricks that we can get into. So if we change our flex direction to column, you can see now it lays out everything vertically. Let's go back to row. It also gives us some nice rules in our spacing. So instead of center, we can do space between. And so what this will do is this will split out the space between our elements, which is really nice. There are other things like space evenly is another one where we'll take into account the edges. There's all kinds of rules you can use there as far as how to space the elements. And then in the wrap, we have flex wrap, we have wrap. And so what that will do is that tells Flexbox, hey, go ahead and wrap my content as the screen starts to get too small. So as we get too small, one by one, they'll start bumping these things to new rows until we get vertical. So super useful little tool, very popular. You can combine this with grid systems, which we'll get into here in a bit. But yeah, Flexbox is very powerful. It's great to place things within a column on a grid system. It's great to lay out a whole page if you prefer Flexbox. Any questions about Flexbox? No, you guys are just on it. Okay, so the last one is grid systems. So grid systems nowadays are probably the most common way that people handle styling. In my opinion, it's the sort of easiest and most robust way to handle your responsiveness. So most grid systems work in a row column layout with 12 columns per row. Some stray from the 12 column layout. I think the only other one I've seen is 24 columns. In fact, materials maybe 24, I can't remember, but it's just more granular. Just about everything runs in a 12 column layout or some factor of 12. So grid systems also allow us to take some control over the breakpoints in our responsive style. So we can assign a column width per media size in our elements. I'll show you this in code in a minute. And so these breakpoints are sort of predefined for us at a certain pixel width by whatever grid system we're using, and then gives us t-shirt sizing. So we'll get something similar like an extra small, a small, a large, or small, a medium, a large, and an extra large breakpoint. And so this takes the strain off of us as engineers to go ahead and make a bunch of media queries to define those breakpoints. We can just add something like, hey, extra small screen, I want this to take 12 columns. So of course, as we talked about extrinsically and intrinsically styled elements, we are turning some of that control over to the browser or the grid system we've decided to use. But it should get us a really good chunk of the way to where we want to be with minimal effort, and we can handle any fine tuning with a few media queries. Now, I will note that grid layouts are a standard part of CSS. This is not something that you have to pull from a component library. You can, in fact, design and define your own grid system with plain CSS, but it's far easier to use one that's pre-built like materials, since we typically use component libraries nowadays anyways. So let's go ahead and take a look at a grid system. Okay, so let's look at this component again real quick. This is Bootstrap or React Bootstrap's grid system. I really like this grid system, probably because I've worked with it a lot. For example purposes, I think this is a great learning tool because it splits out our elements into rows and columns. Let's go ahead and do that real quick. So it's easy to read and under sort of like get in our heads the idea of a row and a column as opposed to materials, which is everything is just a grid. And you give it you say it's a content or an item or both. But so we have one row and it's got 2 column values in it. And then we have another row that's got 3 in it. And you can see I've done no styling over here, no media queries, no percentages or anything like that. But this looks nice and pretty laid out for us already. So here's our first row. And so what Bootstrap is doing here is it's sort of deciding the column widths for us. Hey, there's 2 things in here. So we're going to go ahead and split that up evenly amongst the 12 columns. So each of these is 6 columns wide. Down here, we've got 3, so each is 4. So now we can take a little bit more control over it. And let's say we want this first box to take up 8 columns. And so every grid system has its own sort of like cascade with the media queries. In this case, React Bootstraps cascades up. So this will be anything at an extra small screen and larger. We want to take 8 pixels. So this one now takes up 8, and this one now takes up the remaining 4. Now let's say at like a medium screen size, so at a medium breakpoint, we only want it to take up 7 pixels. So you can see now this takes 7. And as we move down to a smaller breakpoint, it'll jump to 8 at our extra small screen size. So grid systems are really nice because they give us that extra control. They give us those built-in breakpoints that we can sort of leverage to fine tune how we want things to lay out across the page as we move things up and down. So I know that we've all used a bit of grid system, I think both in React or in RapidRef and Swarm. But if you're having some responsive trouble, I don't know if we've gotten into sort of the breakpoint values here. So something we can certainly work on. But yeah, t-shirt sizing breakpoints makes it really easy for us to sort of like fine tune and take some control over our grid system as to how things change in layout as we change our screen or media size. Any questions on grid systems? Cool. Okay, what we have next? Okay, so now let's look at some popular CSS tools. So fortunately for us, there are a lot of libraries, frameworks, and tools that just make our jobs as engineers easier. If you're anything like me, and I think I've heard this from quite a few guys on the RapidRef team, that we sort of like to make things work programmatically. That's kind of how our brains work, far more than we like to style things. I know people who love CSS and there are pros at it. We saw an example of that at the beginning. But I think the general consensus is that programmers would rather eliminate as much overhead as possible when it comes to styling and focus more on the functionality and the whole like making things go, as I like to say, part of engineering. So the main goal of these tools is to write less CSS. That's the main goal here. We want to write less CSS so we can spend more time focusing on functionality and programming. So the first of these is what's called a CSS preprocessor. So Sass and Less are 2 of the more popular CSS preprocessors. I have a quick example of Sass here in a minute. So the best parallel I can think of with the CSS preprocessor is TypeScript. So we write TypeScript. We know that at some point a compiler compiles it down to plain JavaScript. The TypeScript is just a layer there that's there for developer experience. It helps us troubleshoot things. It helps us write things in a way that we like. And then a compiler goes ahead and turns that into plain JavaScript for us. Same thing here. Another term I've used or I've heard is syntactic sugar. So this is syntactic sugar. It doesn't expand the capabilities of CSS, but it does allow us to write CSS in ways that are easier for us to write and manage. And then a preprocessor will process that into plain CSS for us. So let's go take a look at Sass real quick. So I don't have a working version of Sass. To have a Sass compiler would ruin the rest of the components on my page, but we can take a look at some code here and sort of get the idea of what a preprocessor has to offer. So again, here's our same component. So one of the cool things about CSS preprocessors is it allows us to use variables. So say I've got this really complex sagely green color here. I don't have to remember that hex code and go and type it in everywhere I want to color something sagely green. I can go ahead and give it an easy naming convention, sagely green, and I can go ahead and I can use that anywhere in my styles. So here's sagely white. I don't know if this is actually our sagely white, but we can use variables, which is really nice. The other thing is that it allows us to nest our styles. So as you can see here, I have a class name of Sass container. And in fact, let's just get rid of everything else in here. And so we can sort of have our styles match what our component looks like. So you can see we have a Sass container, and we can go ahead and give that a height and a width. But then we can nest this. And so anything inside inside this Sass container, inside an element with the class of Sass container, anything that's a header inside of that, and a div inside that header, and an H1 inside that div, we'll get the color sagely green and the font size of 2 Same thing with the paragraph. We can give it sagely white, font size of 14 pixels. So this nesting styles is really nice because one, it's really easy to read next to a component or an element that you're working on. You can sort of nest it. 2, we can sort of clean up our code. We don't have to apply as many classes. 3, it also helps us a little bit with conflicting styles. Like if we have another, say we had another container with a class of Sass container and it has a bunch of other elements in it, we can go ahead and target those elements by saying, hey, this Sass container looks like this shape, and I want to target these things accordingly. Okay. Any questions on CSS preprocessors?
So when you use these, like you're actually compiling, I assume, like to turn it into regular CSS?
Yeah, so that's a really good point, and a good caveat to call out is there is some extra setup that can sometimes be a pain when it comes to like hot reloading. So I've worked on projects where we've used certain preprocessors that just don't have a setup to hot reload. So every time you go and apply a style, you have to type something into the command, whether it be like a Sass compile or a build or something, to have your styles applied. So yeah, so there is some processing that happens behind the scenes that takes a syntax like this and turns it into plain CSS classes and injects those styles into our elements for us. Does that answer your question?
Yeah.
Yeah, so there is sort of a compile step with your CSS here. Okay, back to Mentimeter. This is just a fun one. Can anybody tell me what Sass stands for? I take it a few of you who've used Sass. Yes, it is syntactically awesome style sheet. Just them having some fun with the naming, but that's the goal here, is they want to change the syntax. They're not changing what CSS does. They're just giving it an awesome syntax. So that's really the piece to hammer home here about CSS preprocessors, is it allows us to write a new syntax that may be better suited for what we're doing. All right, so the next one is CSS in JS. So when React started to get popular, this idea of writing CSS in JavaScript became a popular notion as well. I think I've seen a little bit of CSS in JS. Oh boy. just about all of your projects. But I think it's important to know the pros and cons of CSS and JS. So some of the pros, limited scoping. So styles get applied per component, and this prevents clashes with global scope and specificity. So say we have the same class, two engineers are working on two separate components, they name something the same class, those might clash. Whereas something like CSS and JS scopes things to the component that we apply to. It also allows for dynamic styling, which I think is one of the coolest parts about CSS and JS. So based on a data change, a state change, an event listener, we can change the styles of our page on the fly. It allows for easy theming. I think both RapidRef and Swarm use a Material UI theme, but what this allows us to do is to define some global styles, and we can wrap our whole app component in a theme and apply those styles down. So once we have our theme laid out, we can spend a lot more time just writing code and not really worrying about our styles. Should already be styled for us. And just easier maintenance. It reduces the number of files, and it's easier for somebody who is a JavaScript engineer to sort of like stay in that JavaScript mindset. Now, there are some important cons to this as well. So one, performance. This is JavaScript. JavaScript has to be executed. So when we're writing CSS and JS, the JavaScript has to be executed, which then parses the CSS, which then injects the parsed CSS styles into our components. So there is that execution time of the JavaScript that if we have a bunch of CSS and JS styles, may slow us down a little bit. It also eliminates the ability to cache. So it's a pretty common practice to cache CSS for subsequent page loads, so we don't have to download those from the server every time. But since we don't have any real CSS files, we can't cache our CSS. So then there's just the DOM complexity. This comes a little bit with using CSS preprocessors as well, depending on the preprocessor you're using. But since our styles are scoped per component, this adds overhead and just the sheer amount of styling that gets added into our DOM. It will also sort of append certain IDs to your class names. So say you have two separate components that have the same class name. CSS and JS or whatever is compiling this in the background will append certain IDs to that to solve the scoping and specificity issue. And that's how they sort of differentiate the class from one component to the next. So sometimes if you're like in your inspector in the browser and you're trying to find a certain class, all of your classes may look a little funky because they have all of these IDs at the end. And so it can just be harder to read through. So let's look at some CSS and JS. Okay, so you can see over here, we don't have a CSS file. So instead, we've just created this constant called styles. And then we have a container, a header, and a button, and we've given it some style. So this is just a big JSON object. And so then as we apply these styles, we can give style, we just reference our styles object, and we want this to be our header style or our container style. And so fun example of this, let's just kind of take a look at how this component works. So I have a state object called color and a setter for set color. It defaults to black on page load, but I can go ahead and I can reference that state object in my styles, which is something I can't do in CSS. And then down here, I have this change color function, which gets fired off on the on click of this button. And all it does is it takes this array of colors, it picks a random color, and it calls the set color function to set our state color to whatever random color in the array. So what this allows us to do is, since this is JavaScript, as I click this button, I can dynamically change the styles of my page. So these are just random, but that's a huge advantage to writing CSS and JS is you get this dynamic styling piece, which can be really useful, a lot of fun to use, but kind of opens the doors for us as engineers to apply some JavaScript programming and engineering to our CSS. Any questions on CSS and JS? Cool. Onwards. Okay, so frameworks and component libraries, kind of where we're at today. Frameworks have been around for a while. Component libraries are becoming ever more popular. I think the first popular CSS framework was Bootstrap, which is still maintained. It's still wildly popular. It has all kinds of versions specific to React, plain HTML, and a lot of other languages. And it even includes a React component library as well. The simplest way to look at a framework is just a collection of CSS style sheets that have already been built for us. And we can go ahead and leverage those style sheets and its classes and its styling rules in our own code. Whereas a component library, these are kind of cool because they take a lot of work off of our plate. So not only do things come styled, but they're usually functional as well. So sure, we may need to make some tweaks here or there to get the full desired effect, but this is sort of the beauty of the component paradigm in React. We can take a small piece of code and we can reuse it and plug it in wherever necessary, whether that's our code or somebody else's code. So it's opened up the door for all of these component libraries to come about, and we can start to pull these things, and they're mostly plug and play with not only styling but functionality. So I'm sure we've seen plenty of material UI, we've all used it, but let's go look at some anyway. So as you can see, I'm importing all of these different components that material has already set out for me. They're styled. As you can see, I just go ahead and use those components. I give it a few options. Maybe a little styling if I want. And this is a super simple example, but this has already got a nice slide toggle on it, which if you're into some CSS animation, slide toggle is a fun one to look into. But I haven't had to do any of this functionality. All I've had to do is slap it on, import it, slap it on the page, add my text, and it comes functional out of the box for me as well. So really nice part of component libraries. Talk about writing less CSS. Here we can even write less JavaScript. Any questions about frameworks and component libraries? Okay, cool. Back to Mentimeter. Another fun one. I promise this is the last one of these I will bug you guys with. And that is, who developed Bootstrap? Ooh. Okay, good range here. It was actually Twitter. Twitter developed Bootstrap. There were two engineers at Twitter who developed it. It was originally called the Twitter Blueprint. Twitter liked it. They made it a big open source thing and kind of had this gigantic like hackathon, so to speak. But yeah, Twitter was the one behind the popular framework Bootstrap. Oops, I went right by our slides. All right, so there are a few other ways to style components specifically to React. So we've already gone over component libraries, which is a huge one. But there are a few other things I want to mention that can be good tools for styling React components. Oops. Okay, so the first is a CSS module. And so a CSS module allows us to package a CSS style sheet right in with the JavaScript of our component. So pros and cons here. One, it's plain CSS. So this allows us to skip the whole JavaScript execution piece. So performance is great. It limits scoping and specificity issues. So since our styles are scoped locally to the component as a module, we sort of avoid that conflicting style name. If we have two separate components with the same class, we've imported something as a module that will apply to that component specifically. Since it's CSS, we can cache it. So we can have faster reload times. We don't have to download our CSS sheets from the browser every single time. It's easy to organize our style within the component. It's more files because we have one style per component, but it's pretty easy to find and maintain if you have a good styling or good file system. I'll show you guys that in a minute. And it also allows for CSS preprocessing. So if you really like the syntax of Sass or less, you can use Sass or less in a CSS module. So the cons, this is a small one. There is a global property. So it's just a non-standard rule, but if you want to apply things globally, you have to give it a global keyword. 2, we lose the dynamic styles over CSS and JS, but that's with any CSS that we use that's not JavaScript. And then the third is just TypeScript compatibility. You're going to have to jump through a few hoops to get this all set up. You're going to have to declare your CSS modules as TypeScript modules, or you're going to have to use something like a Webpack loader. Let's go take a look at a CSS module. Okay, so as you can see, I have sort of laid out this whole thing like you would with CSS modules. This is a really great way to do it. Say you have a component called CSS module, you can have its index, which is the component, and then you just package the module right in there with it. I like this layout. It's really easy to just work in one folder. You have your component, you have your styles. The thing here is that you have to name it .module.css. That's really all this takes to use CSS modules. So you can see that we're going to go ahead and import styles. We can name this whatever because we haven't named our export. And we have some classes in here. Now, one of the really nice things about this is that since this is a module, we get some type hinting. So we've imported this thing and I don't remember what I've named all my classes. It's going to go ahead and give me a hint to autocomplete what that is or what my class is. So when I used, oh, this is supposed to be main container. Main container. Oh, that's why it didn't give me main container. And I have an extra C. So it's nice for completing your styles. I think I have a browser demo for this. So you can see this is styled just like our first one, but we've done it all through modules. So just a great way to sort of organize your code. That autocomplete hint is really nice as well. And just really great way to package up your CSS with each component. Any questions on CSS modules? No. Okay. So the final thing we're going to get into is what's called styled components. This has become kind of more popular in the last couple of years. So styled components is a third-party library that basically allows us to redefine a component or element and let us pre-style it, and then use that component in our components that we're going to render in React. Oh, you guys aren't even looking at the slide. This is kind of what it looks like. We'll go ahead and go through a demo over here. Styled components. Okay, so as you can see over here, kind of how styled components works. So where we may have originally had a div here and given it a class, we can go ahead and create a const called styled container. And the styled components library has a div element. So what we're going to do is we're going to say, hey, we want this component to be a div element, and we want to give it the style text align center. Then we can go ahead and create this new component styled container that we've created, and we can use it here as opposed to a div with a class. So we've done the same thing with styled header here. I've gone ahead and I've styled a header element or component, and I have gone ahead and used that new one. So let's go ahead and style our H1 down here, our hello world. So what this would look like, I would go ahead and I declare a new constant. And naming convention around styled components is typically capital as opposed to lowercase. And we're going to go ahead and do this style.h1. And so what we're saying is, hey, we want this component to be an H1, but we want to give it some styles before we use it. So we can give it a color of blue. Let's give it something ridiculous. So we have this new component. Let's go over and look at our styled components. Nothing different yet. But then what we do is where we have this H1 here, instead of going ahead and adding classes to our H1 and adding CSS rules to those classes, we just go ahead and we're going to use the new H1 component that we created up above. So now we're using this H1 component as opposed to the standard H1 component. And our styles have been applied. Oh, I guess 96 wasn't as ridiculous as I thought. But you can see we've applied that style by creating a whole new component outright and using that within our main component that we're trying to render. Any questions around styled components? Okay.
What
Cool.
was that?
Oh, go ahead.
Can you go back to the code?
Yeah.
Say styled H1 and then in ticks you put the style you want, but it's not like in parentheses or anything. That's
No, it
interesting.
is the ticks. I agree. I'm not a huge fan of that syntax. It's a little bit harder to read. But I think the way this probably works behind the scenes is it takes in a formatted string, and that's how it applies our
Can you
style.
still like put a variable in there, like using use state like you did before, like control it, the behavior of it using this way?
Oh, that's a good question. I believe you can, because technically styled components is CSS and JS at some point. So I believe you do have the ability to do some dynamic styling with styled components as well.
Okay.
About like 95% sure on that, but I can confirm that and get back to you guys afterwards. Okay, well, that went fairly quick. So there's a lot to learn in CSS. You can take this to the moon if you want to. I hope that this was just some good exposure to some of the tools and possibilities that CSS has and gives. Hopefully some good tips to keep at the front of your mind when you guys are styling your own products. Just writing better, cleaner CSS. I'll open it up to some questions now, but of course, please reach out to me at any time if you have questions, if you're having trouble styling something or need some clarification, or if you just want to get into some rad CSS like animations and stuff like that. I love working on that stuff. So please reach out if you have some interest in some deeper CSS topics. Any questions?
I have one that's more general, not specific to any of each of these, but when you're doing like pixel measurements, will that be impacted by like if you're on like a 1080p or 4K screen, or is that just more like of a like CSS measurement?
No, it's more of a CSS measurement. It may look a little bit different because your screen is going to read that at so many pixels per inch, but for all intents and purposes, for us as engineers, I would think of this as a CSS measurement as opposed to starting to think about screen pixel density.
So I guess a question I have about style components is, so I've worked with these a bit before. I guess I never really understood what are the advantages and disadvantages of, for example, instead of having a styled H1, just creating a separate CSS class for that styling, that thing that you want.
I think to me, a lot of it is syntax and readability. So I think we're still looking at my code. Yeah, so instead of having to like break out a second style sheet, this is super nice to read, in my opinion. I would have to look into because again, this is CSS and JS. I would have to look at the performance differences between this and other CSS and JS implementations. I would assume there is some hit there because the JavaScript does need to be compiled. But yeah, for the most part, I think when it comes down to CSS, it's just comes down to like what you prefer is readability. In my opinion, this is really nice because I can have an H1. The other piece of this is that we're writing components, and what we know about components is they're reusable. So of course a class is reusable as well, but I can create a bunch of styled divs off of my own library if I want to. And this is a little bit easier to write than, going out and trying to write my own, like, say I wanted to break out another component and we export const h1 equals h1, and then we have a class, class name. Now. Sorry, I'm probably botching this pretty terribly. So we could go ahead and like create another component like that, export it, import it, use it. Oh, it probably doesn't like my H1 or one. So we could do something like this where we go out and create another component, export it and import it. This is just a really shorthand way to accomplish this. So say we want all of our H1s to look the same. We could go ahead and write all the syntax to create that H1 or that header or whatever that component may be. But this is just, in my opinion, much quicker to write than it would be to go ahead and write a whole component in JSX syntax.
Okay, thanks.
All right. Sounds like we don't have any more questions. So keep an eye out in the Sagely app. I will have a curriculum assigned to you guys here shortly. Some more comprehensive sort of CSS tutorials that will dive a little bit deeper into some of the things we talked about, at least in the CSS basics. And then there's a fun little exercise in Flexbox as well. But yeah, so keep an eye out. There will be some work to come along with this. And of course, as you're going through that, Slack me, ask questions. I'm here. I'm happy to answer them. Happy to help wherever I can. Other than that, that is an intro to CSS, specifically in the wavelength domain. All right. Well, happy Monday. Have a good Monday. I will see you guys on the internet.